In this video, we will see about the utility matrices. That is, there are some special matrices and also what will be the operations on these matrices. These are some of the utility matrices, that is I matrix, zeros matrix, ones matrix, random matrix. Then you have random normal distributed matrix. You have diagonal matrix from the vector and diagonal matrix from the matrix, and diagonal matrix with offset. We will see all these here. First is I of m comma n. Here it will return an m by n matrix with ones on the main diagonal. So usually here m will be equal to n. You can write it as I of n or I of m. Okay. So here it should be it will be always a square matrix. I matrix will be always a square matrix and it will produce a identity matrix. I matrix can be used to produce a identity matrix. Next is zeros of m comma n. Here it will return an m by n matrix of zeros. So here it will create a m cross n matrix. That is, the order of the matrix will be m cross n. M will be number of rows, n will be number of columns, and all the elements of this matrix will be zeros. Next is ones matrix, ones of m comma n. Here again it will return a matrix of order m cross n, and all the elements of this matrix will be 1. This is the random matrix. Okay, again here the number of rows are m and number of columns are n, and it will create a matrix where all the elements will be random numbers, and those numbers will be ranging in between 0 and 1. Next is the random normal distributed matrix with order m cross n, and here the numbers which are displayed are the numbers which are taken from the normally distributed numbers. Next you have diagonal vector. Okay, this is diagonal vector which will generate a diagonal matrix with vector v on the diagonal. Then you have diagonal of A. It will extract the diagonal of the matrix which has been given. Here what it will do in diagonal of V will be giving what must be the elements of the diagonal, main diagonal in this. Okay, in diagonal of V will be giving, that is, whichever diagonal element which we want, we will be giving that, and we'll ask it to generate a matrix with those elements as the diagonal elements. Whereas in diagonal of A, we'll be giving a matrix, square matrix, and then we'll be asking to extract the elements of the diagonal, that is the main diagonal. Okay, this is diagonal of A comma 1. Here it will extract the elements from the matrix which are in the upper of diagonal. It will display those elements in the form of vector. It may be a column vector or row vector. Whichever you want, you can, in whichever form you want, you can extract that. So here this is just a brush up. Here I matrix, it will create an identity matrix. Okay, then here it will create a ones matrix with all the elements ones. Random, that is random normal matrix, normally distributed matrix. So here it will create a matrix of m cross 1 with the random numbers from a normal distribution. Then you have diagonal matrix, you have zeros matrix, random matrix, diagonal vector, and diagonal offset. Okay, so first we'll see what is a I matrix. Here A is equal to I of 3. Whenever you write this command in the MATLAB, you will get this matrix, that is A is equal to 1 0 0 0 1 0 and 0 0 1. This will be displayed in the command window. So here it has created what? It has created a n cross n identity matrix, that is 3 cross 3. Then we have zeros matrix. B is equal to zeros of 3 comma 2. This will be writing in our editor window. So here zeros 3 comma 2, it will generate a row, it will generate this matrix where it has 3 rows and 2 columns. So it has created a matrix of what order? 3 cross 2. Next you have again B is equal to ones of 3 comma 2. It will create a matrix where it has 3 rows and 2 columns, and all the elements of this matrix are 1. Okay, so 3 cross 2 matrix. Next we have A is equal to random of 3 comma 2. So it will create a matrix where it has 3 rows, 2 columns, and these are the random numbers. Okay, the elements of the matrix are random numbers, and these will range in between 0 and 1. Next you have A is equal to random of normal distribution 3 comma 2. So these elements will get. See the difference here. When you are giving just random of 3 comma 2, these are the elements which are been taken, and when you are taking from the normal distribution, these will be the elements. Here you don't have any negative number. Here you will get some negative numbers because these are taken from the normal distribution. Next, about this is about the diagonal vector. Here we are giving the vector as input, that is V is equal to 1, 2, 3, and what must be the matrix which has to be created? B is equal to diagonal of V. That is, we have to create a matrix with B. We need to generate a matrix B with the diagonal elements as 1, 2, 3. So this will be the output. B is equal to 1, 0, 0, 0, 2, 0, 0, 0, 3. So these are the diagonal elements. Now again we have A is equal to this matrix, which is a 3 cross 3 matrix. I want to extract the diagonal elements from this. Okay, so A is equal to this to generate the matrix, that is 1, 2, 3 semicolon 4, 5, 6 semicolon 7, 8, 9. Then B is equal to diagonal of A. So this is about the diagonal matrix. Previous one was about the diagonal vector. This is about the diagonal matrix. We are giving the matrix. We want to extract the diagonal elements. Diagonal elements in this matrix are 1, 5, 9. So it will display it in the column vector, that is 1, 5, 9. Next again the same matrix we are taking here. Okay, now we want the upper diagonal elements. This was our main diagonal. This is the first upper diagonal elements, that is 2, 6. So for that, this will be the command B is equal to diagonal of A comma first upper diagonal element. Okay, elements. So B is equal to 2, 6. So 2, 6 are the upper diagonal elements of this matrix. Next, suppose we want to create a matrix. We want to generate a matrix, and these are the specifications or details of the matrix which we want to create. So B is equal to ones of 3. Here what we are doing is we are using these all elementary matrices, and we are creating or generating a overall matrix. So B is equal to ones of 3. It should contain a matrix of order 3 cross 3 with all the elements 1. Then zeros. It should contain a matrix of 3 cross 2 with all elements zeros. Then in the second row, okay, this is about the second row, that is according to this matrix. Okay, whatever we are giving, this is about the second row, but here it will create 3 rows 3 columns. Okay, here. Then next here zeros of 2 comma 3, it will create a 0 matrix of order 2 rows and 3 columns. Then last one is I of 2. It will create an identity matrix of order 2 cross 2. Then we are multiplying that matrix with a scalar 4. That is, we are multiplying all the numbers with number 4. This will be the matrix here. What it is doing, it is creating a matrix B using the sub matrices. That is all the elementary matrices, which are those ones, zeros, and I. So here first what we have given, ones of 3. So it has created a identity matrix here. Sorry, not identity matrix. It has created a 3 cross 3 matrix with all the numbers 1. So it is ones of 3. Next, zeros, 3 rows 2 commas. Sorry, 2 zeros. 3 rows 2 columns. 3 rows 2 columns where all the elements are zeros. Then here zeros of 2 comma 3. 1, 2, 3. Here 2 rows 3 columns. Then next identity matrix, which is multiplied with 4 of order 2 cross 2. So 4, 0, 0, 4. Okay, this is how you create the matrix by using the elementary or the sub matrices. Now suppose we have a matrix of order 5 cross 5, and I want to display the diagonal elements from this main diagonal elements. So I can write here C is equal to diagonal of B, but I want this to be expressed in term of in the form of row vector. So what I have to do is diagonal of B and transpose. Okay, so I'll get C is equal to 1 3 5 7 9. So it will pulls out the diagonal B in a row matrix. Next, C is equal to diagonal of B. Here we have written B transpose, so it is giving in the form of row vector. Now, if I am not writing here transpose, it will give in the form of column vector. Okay, so it will pull out the diagonal B in a column matrix. Now, suppose we have this matrix of order 4 cross 4, that is B matrix. So here C is equal to, now I want what? I want the upper diagonal elements. This was the main diagonal. Upper diagonal elements are 2 4 9. I want to display it in the form of row vector. So what I have done here, C is equal to diagonal of B comma 1 transpose. Okay, so this second argument, this one, it will what it will do, it will specify the off diagonal vector to be pulled out. Okay, then here what we'll get the first upper of diagonal vector. First upper of diagonal vector is what? It is 2 4 9. So here you'll get C is equal to 2 4 9. This will be in the form of row. Why row? Because I have typed here single inverted comma, that is nothing but the transpose. If you remove this, it will give in the form of column. Now this was about the first upper of diagonal. Now if I want the lower of diagonal, okay, first lower of diagonal vector, what is that? It will be 2 7 6. Okay, so for that what I have to write here, we have written plus sign, no, for upper one. For lower we have to write it as minus. Okay, so what I will get here, I will get 2 7 6. For upper it should be positive, for lower it should be negative. If you want the second upper of diagonal, you have to write here it as 2. Then you will get 3 5. If you want lower second lower of diagonal vector, then it will be 6 5. Okay, so here you have to write it as minus 2. Plus 2 here and minus 2 here. Then suppose I want to create a matrix where I will give what must be the main diagonal elements, what must be the first upper of diagonal elements, what must be the lower of diagonal elements. So here I am giving D as 2 4 6 8. This must be my main diagonal elements. Then D1, this must be my first upper of diagonal elements, minus 3 minus 3 minus 3. And lower of diagonal, second lower of diagonal elements must be minus 1 and minus 1. Okay, so I have to write in MATLAB as, first I have to specify all these elements, then I have to write this expression D is equal to diagonal of D. Okay, so this will be diagonal of D, diagonal of D. So this will be my main diagonal elements. Then diagonal of D1 comma 1, this will be my first upper of diagonal vector, plus elements, plus diagonal of D2 comma minus 2, this will be my second lower of diagonal elements. Okay, now we'll see what matrix, overall matrix, what we will get. We'll get it like this. What I have given, my diagonal element should be this, that is diagonal of D. So 2 4 6 8, I'm getting that. Next, first upper diagonal elements must be minus 3 minus 3 minus 3. So diagonal of D1 comma 1. So we are getting minus 3 minus 3 minus 3. This is the first upper diagonal elements. This is the second lower diagonal elements which we have not specified, so it is displaying it as 0 0 0. But we have specified what must be our second lower diagonal elements, that is minus 1 and minus 1. So these are the second lower diagonal elements. So it is diagonal of D2 comma minus 2. Minus 2 means it must be the lower diagonal elements. Okay, we will see all these execution in MATLAB here. Here we'll see how to create a I matrix. I matrix is EYE, I matrix, where we will be having all ones in the main diagonal. Okay, so here EYE of N. Okay, N is nothing but the order of the matrix. So here we'll specify the order of the matrix as 3. I'll close this round bracket. Now we'll execute and see this. That is, we'll run this. So here we are getting a 3 cross 3 matrix. Okay, that is, there are 3 rows and 3 columns in this matrix where the main diagonal has all ones in it. Now if I write here I of 3 comma 2, okay, if I run this, here I am not getting the main diagonal, okay, but here some elements I am getting as 1. But it is better that you create a square matrix with this I matrix. So we need to create a square matrix of this, that is with equal number of rows and equal number of columns. Suppose I'll put here 4. Now the order of the matrix is 4 cross 4. We'll run this. So here we are getting the main diagonal. When you are putting the number of rows and columns as different, then you will not get the main diagonal there. Okay. So it works good for the when the order of the matrix is same. Okay, that is when the number of rows and columns are same, not order of the matrix is same. The number of rows and columns of the matrix are same, then we will be getting the main diagonal here, where all the elements of that will be equal to 1. So this is about the I matrix, that is it will create an identity matrix. Now next we will see ones matrix. Okay, ONES, ones. In bracket, here you can put the number of rows and columns as different. 3, 2 I'll put. Okay, I will assign a variable to this. A is equal to, it will create a matrix of all elements with 1, and the number of rows will be 3 and the number of columns will be 2. And this. So here you can see A matrix has been created, okay, where all the elements of this matrix are what? All are 1. It has 3 rows and it has 2 columns. Fine. Next we'll see the 0 matrix. I'll take the variable as B is equal to ZEROS, zeros of. Here also you can create a matrix of any size. So here I'll take it as 2 rows and 3 columns. Okay, run. So here you can see a matrix B has been created where you have 2 rows and 3 columns, and all the elements of this matrix are 0. Next we will see how to create a random matrix. So random matrix, I'll take C is equal to RAND, random, bracket, m comma n. Okay, m comma n, number of rows and number of columns. Close the round bracket. Now run. So here you can see you will be getting some values in decimals which will be ranging between 0 to 1. Okay, so this is the random matrix where we have created a matrix with 4 rows and 3 columns. Fine. Now we will create another random matrix which we will where we will get the values from the normally distributed numbers. Here instead of writing just RAND random, we will write it as RANDN. Okay, now see the difference of the values what you get. Here we are getting all the values as positive when we were writing the command as just random. So run this. Here you are getting some negative values also. Okay, so here these values are taken from the normally distributed values. Fine, sorry, normally distributed numbers. Next we will see diagonal vector. Now suppose I have a vector V. First I will show you what is a diagonal matrix. Now I will be creating a matrix A. I have to create a matrix, square matrix. Okay, whenever I am talking about diagonal, it should be a square matrix. A is equal to 1 space 2 space 3, put a semicolon, 4 space 5 space 6, put a semicolon, 7 8 9, close the square bracket. Now this will create a what? It will create a square matrix of 3 rows and 3 columns where we have specified the elements in this run. So here we are getting this as the square matrix of size 3 cross 3. Now I want to extract only the main diagonal elements from this. So if I want to do that, what are the main diagonal elements here? These are 1, 5, 9. Now if I want to get these main diagonal elements in the form of the vector, I will write the command as B is equal to, I will assign the variable as B. B is equal to DIAG, diagonal in bracket, opening round bracket, A. What is our matrix which we are giving to get the main diagonal elements? It is A. So A. Fine. Run this. Now you can see you are getting a column vector, okay, where it is specifying what it has extracted the main diagonal elements 1, 5, 9. So here we have got the main diagonal elements in the form of a column. Now suppose if you want the main diagonal elements in the form of a row, that also you can do. Here A is there, no? Just you write here single inverted comma. You type here single inverted comma and see what happens. So now we are getting in the diagonal matrix. So whatever row vector, column vector was there, it has been transposed to row vector. Okay, this is how you extract the main diagonal elements from the matrix. You can display it in the form of column matrix or in the form of row matrix. Now next is diagonal vector. Now we have seen the diagonal matrix. Now we'll see what is diagonal vector. Suppose I will give a vector v is equal to, it is a row vector. You can give the column vector also. Later on you can put a transpose there. I will be giving a row vector 1 space 2 space 3 and I want to display this row vector in the main diagonal of the matrix. So what I will do is v is equal to 1, 2, 3. I am giving a row vector. I want to create a matrix where the diagonal element should be 1, 2, 3. So B is equal to DIAG, D opening round bracket, and what vector what variable we have assigned to this vector? It is V. So V, close the round bracket. Okay. Here you are getting some error vector. Okay. B is equal to diagonal of V. Here I have taken capital V. I have to give it a small v because MATLAB is case sensitive. Okay. So here I have used capital V and here I have written small v. So here we are getting some error. Now I have made both v's as small case. So run it. Now you will get a matrix B where the main diagonal elements are 1, 2, 3, which we have given in the form of a row vector. Okay. Now next we will see about the diagonal offset matrix. That is, we will give a square matrix. We want the upper diagonal elements and the lower diagonal elements. Suppose I will give a square matrix capital A is equal to 1 space 2 space 3. Then I have 3, I'll take 4, 5, 6, then 7, 8, 9. Okay. So this will create what? It will create a square matrix of order 3 cross 3. Now suppose this is our main diagonal. That is the elements which are 1, 5, 9. Okay, these are the main diagonals. The upper of diagonal or the upper first diagonal, it is what? 2 and 6. And the first lower diagonal elements are 4 and 8. I want to extract these two. How I can do it is, suppose I'll take a matrix B, okay, that is equal to diagonal DIG in bracket the matrix which I have taken, that comma the first, okay, that is the first upper diagonal elements 1, close the bracket. Now run. So you are getting 2, 6. So 2, 6 were the elements here. You can see, no, 2 and 6. This is the main diagonal 1, 5, 9 and 2, 6 is the first upper diagonal elements. These are the first upper diagonal elements, that is 2 and 6. So it is displaying here 2 and 6. You can see here 2 and 6. Now suppose I want the lower diagonal elements. What are the lower diagonal elements here? 4 and 8. Yes, no? Lower diagonal elements are, first lower diagonal elements are 4 and 8. So here I will take another matrix C is equal to dig in bracket capital A, that is a matrix, and minus 1. Okay, now run. So you are getting 4, 8. So when you want the upper diagonal elements, you have to write it as positive. That is, the number should be positive here. And when you want the lower diagonal elements, this number should be negative. Okay. So here you can take the second upper diagonal elements also. If your matrix is of large size, that also you can take. Here this is for the first upper diagonal. This is the second upper diagonal elements. Okay. If you want second upper diagonal elements, then you have to replace this 1 by 2. For upper it is positive and for lower it will be a negative number. Okay, this was about the diagonal offset matrix, or the first upper diagonal, second upper diagonal, or just upper diagonal and the lower diagonal elements. Now we'll see one example where we'll create a matrix B, and whatever matrices, that is the elementary matrices we have seen till now, will all combine with that, and we will create a new matrix. So B is equal to opening square bracket ONES ones in bracket 3. Okay, so here it will create a 3 cross 3 matrix, which is an identity matrix, which will be having, sorry, not identity matrix, it will be having all the elements as 1. Then next, zeros, zeros, zeros in bracket 3 comma 2. Okay, this must be in the first row. That is, this we are giving it as a first row. What should be our first here this will be first row elements. Okay, but here actually we are giving the sub matrices in that. Semicolon, zeros, zeros, opening bracket 2 comma 3, closing bracket, then space. I will take a matrix of EYEI, okay, which will create what? It will create a identity matrix. I'll take it as of order 2, close the bracket, then I'll multiply it by a scalar 4. That is, all the ones get multiplied by 4. Okay, now close the bracket, close the square bracket. Now run this. See, first we have given ones of order 3. It has created a identity matrix of order 3 here. Next we have given zeros of 3 comma 2. It has created a matrix of order 3 comma 2 where it has all zeros, 3 rows, 2 columns. Next here again it has created a matrix of order 2 comma 3, that is of order 2 cross 3, where all the elements are zeros, 2 rows, 3 columns. Next you have a I matrix, I of order 2, 2 cross 2, where all the elements are multiplied with 4. So here you are getting 4, 0, 0, 4. Okay, this is how you can create a overall matrix by using the sub matrices. Now we will see another example. Okay, where we want to extract some values. So here I'll take again capital B. Capital B is equal to opening square bracket 1, 2, 3, 4, 5. Okay, this will be the first row. 2, 3, 4, 5, 6, second row. Then 3, 4, 5, 6, 7, space 7, third row. Then we will be having 4, 5, 6, 7, 8. This will be the last row, fourth row. Okay, I will run this. This is the matrix which we are getting. Okay, so we want to create a square matrix, no? So this is not a square matrix. The number of rows and columns are different. I will add one more row here. So here I'll take 5 space 6, 7, 8, 9. Now we'll run it. So here we have created a square matrix of order, how much? 5 cross 5. 5 columns are there and 5 rows are there. What is the main diagonal here? 1, 3, 5, 7 and 9. These are the main diagonal elements. Okay. Now we want to display that. C is equal to DIAG, diagonal of what? B. Okay. Run. So the main diagonal elements are what? 1, 3, 5, 7, 9. Okay. We got this in the form of what? In the form of a column vector. We want this in the form of a row vector. So I'll take it as D. D is equal to DIAG, diagonal of what? Diagonal of B matrix, that is capital B, then a single inverted comma. Right. So earlier the main diagonal elements were displayed in the form of column. Now these are displayed in the form of rows. Okay. So one more example we'll see here. Now suppose I'll take the same matrix. Okay. Now I want only the upper of diagonal elements. First upper diagonal elements. So this is the main diagonal. That is 1, 3, 5, 7, 9 is a main diagonal. Second diagonal, first upper diagonal elements are 2, 4, 6 and 7. We'll see we'll get or no. I'll take C is equal to, okay, DIAG diagonal, then B, comma 1. Run it. I should get what? 2, 4, 6, 8. So I'm getting 2, 4, 6, 8. Okay. If you want to express this in column, in row, put a inverted comma here. Run. So this will be displayed in the form of a row. Okay. Now suppose I want the second upper of diagonal elements. What I will do is, second upper of diagonal elements are what? 3, 5, 7. First were 2, 4, 6, 8. Second is what? Second is 3, 5, 3, 5, 7. I will just change this number here to 2 and I'll see what I will get. I'm getting 3, 5, 7. Okay. Now if I want the lower diagonal elements, second lower diagonal elements. What will be the second lower diagonal elements here? Second lower diagonal elements will be 3, 5, 7. Yes, no? 3, 5, 7 again. So here it were 3, 5, 7 and this is also 3, 5, 7 only. I will change here. I'll change this to -7 and see it. Now I changed some elements in the main diagonal. So here 7 I have made it as negative, sorry, CLC. I'll run it. Now we will run this. This is the second upper diagonal element. Now we want the second lower diagonal elements, -2. Okay, lower element -2, upper one +2. So I'm getting it as 3, 5, 7 because I've changed it here. No, I have made it as -7. So now I'm getting it as 3, 5, -7. These are the lower diagonal elements. Okay. Now one more example we'll see here. Suppose I will give some matrices and I want to create a matrix from that. I will give a row matrix 2, 4, 6, 8. Okay. Then D1 should be what? My D1 should be, it should be -3 space, -3 space, -3. Then D2, it should be -1 space, -1. Okay. Now, I want to combine all these three matrices in one matrix. So, my main matrix capital D, it should consist of what? It should consist of the elements of the first matrix, that is here this is a row vector. Now I want to create a matrix where this row vector element should be my diagonal elements. Okay, so I'll give it as diagonal of D. Okay, so here this command, it will create the matrix where the diagonal elements will be 2, 4, 6, 8. Now D1 is my upper diagonal elements. Okay, these -3, -3, -3 should be my upper diagonal elements. So plus DIAG D in bracket D. Okay, D1 should be my upper diagonal elements. So D1 comma 1. So it will create this as the upper diagonal elements. Then plus, now I want to specify the lower diagonal elements. Lower diagonal elements should be from the row vector D2. So D2, sorry, diagonal, DIAG, diagonal, opening bracket, D2, then comma, it should be -1 because it is a lower diagonal element. Okay. Now close the round bracket, close the square bracket and see. What you are getting here. Oh, sorry. It should be -2. Sorry, 2 and -2. Now we'll see. Error in line 4. Okay, D is equal to diagonal of D. First it is correct. Then next is diagonal of D1 comma 1 only it is. Okay, 1. Then plus, okay, here I'll remove the square brackets. I should not put the square brackets. Just I have to give this expression. Now you'll get, see. So D here, what we have specified, D should be our, these elements should be our diagonal elements. So 2, 4, 6, 8. Here you can see 2, 4, 6, 8 are the diagonal elements. Then next, upper diagonal elements must be -3, -3, -3. That is DIAG, D1, comma 1. This is D1. Okay. -3, -3, -3. Upper diagonal elements. D2, these are the lower diagonal elements. That is, just a minute, it should be lower diagonal elements. That is D2, comma -2. Wait, if I put here -1, what I'll get, I'll see. It should be -2 only. That is the lower diagonal elements. Run. Okay. So here D2, we have not taken the first lower diagonal elements. Okay, first lower diagonal elements, here it is 0, 0, 0. It is 0, 0, 0. We are specifying the lower diagonal elements, that is -1 and -1. If I want to specify here the first lower diagonal elements, then this D2 row vector, it should have one more element. We'll do it and see. Suppose I'll put here -1. Now I can change it to -1 here. Now run it. Now we are getting correct. Okay. So the length should be matched, otherwise we'll get an error. So these all were the matrices. That is the utility matrices. So these all we have seen about the utility matrices and their manipulation. I hope you have enjoyed the video. Thank you. I think one more was left here. Just a minute, we'll see that. No, all we have done. Okay, we have done with all. Thank you.